Hello, how are you? Hope that you are all fine today. This is Mrs. Rasada from Science Team at International Language School. So today we are going to talk about the Unit 2, Lesson 1, Atmospheric Layers, Part 2. In this video, we are going to talk about the atmospheric layers, troposphere, stratosphere, mesosphere, and finally thermosphere. So first, do you know that the atmospheric envelope consists of four layers above the sea level, which are classified according to number one, the change in the atmospheric pressure, and number two, the change in temperature. And about the layers, we have four layers: troposphere, stratosphere, mesosphere, and finally thermosphere. And there is a region between each two layers, which are number one, tropopause. It is a region between troposphere and stratosphere. Number two, stratopause. It is a region between stratosphere and mesosphere. And finally, mesopause. It is a region between mesosphere and thermosphere. So first, we are going to talk about the troposphere. It means the disturbed layer give reason because all weather changes take place in it. And about the location, it is the first layer. And about the thickness, it extends for about 13 kilometers above the sea level to tropopause. And finally, the pressure, atmospheric pressure decreases as we go up until it becomes 100 millibar or 0.1 bar at its top, which equals 0.1 of the normal atmospheric pressure. Importance: all weather phenomena are present in troposphere layer. Give reason because it contains about 75% of the total mass of the atmospheric air, and don't forget the information. Number two, the troposphere layer organizes the Earth's temperature. Give reason because it contains 99% of the water vapor. And don't forget this information. And what about the weather phenomena, such as rains, winds, and clouds, take place in troposphere layer that form the weather conditions that affects the activities of living organisms. Number five, the air movement. Air movement in this layer is vertical. So because the hot air currents have less density, so it will move upward, and the cold air have higher density, so it will move downward. And about the temperature of this layer decreases at the rate 6.5 Celsius degree for each 1 kilometer height until it reaches the lowest value of about minus 60 Celsius degree at tropopause. So we can calculate the amount of change in the temperature in troposphere layer using the relations. Number one, changes in temperature equal the height times 6.5. Change in temperature equals the temperature at foot minus temperature at the top. And we can calculate the temperature at the top of a mountain or at its foot from the following relations. The temperature at the top equal the temperature at foot minus decreasing in the temperature. And about the temperature at foot equal the temperature at top plus increasing in temperature. And now we're going to talk about the stratosphere. It is called the ozonic atmospheric envelope. Give reason because it contains most of ozone gas. And about the location, it is a second layer and thickness. It extends from tropopause 13 km to stratosphere 50 km with the thickness of 37 km. And about the pressure decreases as we go up until it becomes 1 millibar, 0.001 bar at its top, so which equals 0.001 of normal atmospheric pressure. And about the importance, it contains most of ozone gas O3, which extends from 20 km to 40 km height above sea level. So it's called the ozonic atmospheric envelope. And number five, the air movement. The lower part of this layer doesn't contain clouds or weather disturbance, and the air movement is horizontal. So pilots prefer to fly their planes in this lower part of this layer. And what about the temperature? At the lower part, the temperature is constant and measured minus 60 Celsius degree, then increases gradually until it reaches 0 Celsius degree at the top of this layer. Give reason due to the absorption of ultraviolet radiation or ultraviolet rays coming from the sun by using layer which is presented at the upper part of this layer. And now we have here mesosphere. It is a middle layer, so it's called mesosphere. So meso means middle. And what about the location? It is the third layer. And about the thickness, it extends from stratopause 50 km to mesopause 85 km with a thickness of 35 kilometers. So what about the pressure? Atmospheric pressure decreases as we go up until it becomes 0.01 millibar as at its top. And the importance, it protects the planet Earth from celestial rock masses due to the friction with air forming luminous meteors. And what about we have here question: mesosphere is much vacuumed or highly rarefied because it contains a limited amount of helium and hydrogen gas only. And what about the temperature? Mesosphere is considered as the coldest layer. Give reason because the temperature in this layer decreases at a high rate as we go up until it reaches minus 90 Celsius degree at its top. And although meteors are burned in mesosphere layer, spaceships don't burn during passing through it because their conical fronts disperse the heat and their tails are made up of insulated materials. And number four, the thermosphere. It is called the thermal layer because it is the hottest layer as the atmospheric envelope. What about the location? It is the fourth layer of atmospheric envelope. And what about the thickness? It extends from mesopause 85 km to height of 675 km with a thickness of 590 km. And about the temperature, increases at high rate as we go up until it reaches 1000 Celsius degree at its top, so it's called the thermal layer. And the upper part of thermosphere layer is called ionosphere because it contains the charged ions. And what about the ionosphere layer? It is a layer that contains the charged ions and it exists in the upper part of thermosphere and extends up to 700 km above sea level. And what about the importance of it? It's very important in wireless communication and broadcasting because it reflects radio waves to communication centers. And what about the Van Allen belts? Look at this picture. Ionosphere is surrounded by two magnetic belts known as Van Allen, which is related to the scientist Van Allen who discovered them. So there are two magnetic belts surrounding the ionosphere. So, and its importance as these belts help in scattering the harmful radiation away from the Earth, which cause the occurrence of aurora phenomenon. An aurora phenomenon is a phenomenon that appears as brightly colored light curtains seen at poles of north and south pole of the Earth. And now look at this picture. It is the exosphere layers. It is a region in which the atmospheric envelope is inserted in the outer space. And about the importance, satellites float in exosphere around the Earth are used to transmit weather conditions information in TV programs. And the Egyptian satellite NightSat transmit a number of different educational channels which you can watch through the digital space channels. And I think that's enough for today, and thank you so much. See you later. Goodbye.